Okay, so this next method is called completing the square, and in order to understand why it works, we have to understand a factoring pattern first. So we're just going to play with factoring for a second. No, sorry, not a factoring pattern. We're going to play with multiplying out first and then recognize a connection between a factoring pattern and the original foiled form. But if I asked you to expand x plus 1 squared, what would you do? Well, x plus 1 squared means x plus 1 times x plus 1. And if I FOIL it out or double distribute, depending upon how you want to look at that, I would get x squared plus 1x plus x plus 1. And then when I combine like terms, I get x squared plus 2x plus 1. Okay, so right now, anything jump out at you? Probably not. You know, in order to see a pattern, we have to do it a couple of times. So let's try this x plus 2 part. Okay, so if I multiply that out, I get x squared plus 2x plus 2x plus 4. And so we get x squared plus 4x plus 4. Now, at this point, I want to pause real quick. The pattern I want you to look for is I want you to look at the original numbers and the two things that showed up in the multiplied out form. Well, what's the connection between a 1 and a 1 and a 2 and a 4? What do they have in common? How do you go from, what do you do to 1 to end up with 1? And that's the same thing you do to a 2 and end up with a 4. Do you notice that we are squaring that? Okay. So, in other words, this last number and this last number, so this guy and this one, they're squares. And 1 squared happens to be 1, so it works out nice in that case. The other thing I want you to think about is how do you go from a 1 to a 2 and a 2 to a 4? What different pattern do you have there? Hopefully you realize, oh, we're doubling it. So if that's true, then this, x plus 3, and I'll write out. So we'll do it the long way. But if it's true, if we recognize the pattern of what we think it is, it's going to be x squared in the front. We're going to double that term, double the 3x, so that's 6x, and square the last, we end up with a 9. So let's work it out the long way and see, is that in fact true? So we get x squared, we get plus 3x plus 9. Did our pattern hold? Yeah, it did. Okay, so at this point, we've got a very powerful shortcut, very interesting observation. I don't have to expand it out and multiply term by term. I can jump straight to the end. Okay, because the pattern happens to be that I want to square the first term. So that's that x squared. Then I want to double the product. So 4 doubled is 8x. And then I want to square the second term. So if I square the second, I get 16. So 8x x squared plus 8x plus 16. Okay, try the other two for a second. So pause me, whatever you want to do the video, but see if you can figure out the next two without having to actually expand anything out. And hopefully you got x squared plus 14x plus 49 for that one. And this is x squared minus, did you catch that? 16x plus 64. Okay, so we have this very interesting pattern where if it starts off at the basic x plus a number and we're quantity squaring that, we have this square the first, double the product, square the last pattern. Now anything that's of this form, anytime that we can apply that process, we call that a perfect square trinomial. Okay. Well, let's continue with this investigation, but let's change the information we're given. So here, I've got x squared plus 12x, so we're saying that we've used this square the first, double the product, square the last, and so we have to come up with what happened. Well, if this 12x is based on double the product, what did you double to get 12x? And that's 6, positive 6. So what does that last number have to be? That has to be a 36. Okay. What about x squared minus 18x? What do you double to get negative 18? Hopefully, you caught on to negative 9, and so the last number has to be 81. Okay, now going back to some guidelines and expectations for when to use the square root method. This method is actually always going to work, but as you'll see, it's a little bit more work than some of the other methods. So I would honestly only use this if I was unable to use the factor method or the square root method. If I couldn't get those two methods to work out, maybe I would come back to this one. The other thing to notice about the completing the square method, that it really is only convenient if the equations have a leading coefficient of 1 and the middle term happens to be even. So it does work, and we'll look at some examples of when it doesn't necessarily follow those rules, but it does work in other cases. But I wouldn't apply completing the square unless it's, so if I get to pick, I wouldn't do completing the square unless it had those conditions brought upon it. But again, we'll look at some particulars as to why that works. Okay, so the steps for completing the square are from standard form. We're going to make a equal to 1. So if there's nothing there, I mean, if it's already 1, we're great and we don't have to do anything. But if there is something there, then we're going to divide each term by a, and that will get it to say 1. Then we're going to move the constant term to the right side of the equation and add blanks to each side. Again, I'll model this so you can kind of go, what? Why are we adding blanks? Then we're going to complete the square by dividing the linear term by 2 and squaring. And then that squaring number is what we're going to put in the blanks. The right side will now factor into a perfect square, and that's that perfect square trinomial that I was talking about earlier. And then we'd finish solving the equation by using the square root method. Okay, so again, completing the square by itself isn't going to get us the answer for x, but when we combine it with the square root method, then it's a very powerful method. Okay, so let's actually take a look at some examples of this and see what I'm talking about. So we have x squared plus 10x plus 21, and leading term is 1. It's got an even middle term, so this thing is perfect for completing the square. So our first step is to move the 21 over. So x squared plus 10x plus blank equals negative 21 plus blank. Okay, so then from here, I want to look at that middle term. So middle term I want to divide by 2, and then I want to square it. And that number right there is what's going to go in those two blanks. So x squared plus 10x plus 25 equals negative 21 plus 25. And on the left side, it's perfect for that. It's that perfect square trinomial, so that factors into x plus 5. So that number there ends up going in that position. And on the right side, we happen to have 4. Okay, so this is where the square root method is now going to take over. So completing the square got us to this point. So now we're going to finish this thing off with the square root method. So take the square root of both sides, and I end up with x plus 5 equals plus or minus 2. So that means negative 5 plus or minus 2. And I can split that up into negative 5 plus 2 and negative 5 minus 2. And so our solutions would be negative 3 and negative 7. Okay. Now, take a look at the next one. And that 2x squared plus 14, is that set up? Is it kind of like we want it to be? It's debatable. Because we've got that 2 out front. But if we don't have a 1, if it's not a leading coefficient of 1, we can go in and divide everything by 2. And so I end up with x squared plus 7x plus 2 equals 0. And so now we're going to see why an odd linear term is not the most convenient of the bunch. It's a little bit nicer if they're even numbers, but we can still work with this. So I'm going to move the 2 over. So x squared plus 7x plus blank equals negative 2 plus blank. Okay, so then I want to do the divide by 2 and square. So 7 divided by 2 is our, I guess that the b term. And then I want to square that. There's 49 fourths. So that, believe it or not, is what we're going to add to both sides. And this will typically happen whenever we have an odd middle term. We'll end up bringing fractions into the problem, and that, again, that's okay if that happens. Now, on the left side, so we can put that into factored form, we have x plus, remember this number goes in that blank there, so x plus 7 halves. Remember, it's double the product, so if you double 7 halves, you get 7. Square the last, we get 49 fourths, so it works. Over here, we have negative 2 plus 49 fourths, so I'm going to rewrite that as negative 8 over 4 is what I want. And, alright, so that would be x plus 7 halves squared equals 41 over 4. And now I want to apply the square root method. So the square root method would be, square root both sides. X plus 7 halves, so I'm doing the parentheses there, equals plus or minus the square root of 41 over 2. A little more room here. Then I want to subtract off that 7 halves. Alright, and that's a perfectly good answer right there, actually. Nothing really, I mean, I could bring it together, but it's a fine number the way it is. So we get the plus 1, and we get the minus 1 would be our 2 answers for that. Alright, third example. We don't start off with a leading coefficient of 1, so I'm going to divide everything by the 3. So we get x squared, 18 over 3 is 6x plus 7 equals 0. Okay, and then I'll put it into, bring the 7 over, so put a blank there. So negative 7 plus blank. All right, and then we can apply completing the square, so negative 6 over 2 is negative 3, and I want to square that, so I get 9. So we're going to add 9 to both sides. So on the left, I get x minus, remember this number shows up in the blank, so x minus 3 squared, and then negative 7 plus 9, I get 2. Then I want to take the square root, so x minus 3 equals plus or minus the square root of 2, and can't really simplify the square root of 2, so I get x equals 3 plus or minus the square root of 2, and that's it. That's probably a perfectly fine answer. So I have 3 plus the square root of 2 and 3 minus the square root of 2 as my two solutions. All right, so our last method for solving a quadratic is called the quadratic formula. I personally call this the sledgehammer of solving. It will always work, it's just not pretty. So the guideline for it is that it always works, but use as a last resort. Unless the directions tell you that you have to use it, try one of the other methods. Sometimes completing the square will actually work quicker than this one will. Now, as far as the steps involved, we want to put it into standard form. And just a reminder, that's ax squared plus bx plus c equals 0. Then we want to find the values of a, b, and c, and we want to substitute that into the formula, which happens to be this lovely thing. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, that is something that I would expect you to memorize. If you do a quick search, I'm sure you can find lots of illustrations of people singing it or come up with clever little ways to get it in your head, but it's not that bad to get done.
What is the quadratic formula? X equals negative b plus or minus the square root p or minus RAC over 2a. X equals negative b plus or minus the square root equal minus RAC over 2a.
Okay, so in this first example, it's not in standard form, so we're going to have to move some stuff over. So I'm going to have to subtract off the 3x from both sides, and I'm going to have to add 2. And so I get, let's see, so we get x squared plus 6x plus 13 equals 0. So a in this case is 1, b is 6, and c is 13. So then substituting those values into the quadratic formula, I get negative 6 plus or minus the square root of b squared minus 4ac all over 2a. Alright, let's see, so negative 6 plus or minus 36 minus 52 all over 2. 36 minus 52 is negative 16 over 2. There's that negative again inside the square root. So let's see, the square root of 16 is 4, but negative 16 would happen to be 4i all over 2, so we end up with negative 3, negative 3 plus or minus 2i. That's a perfectly fine answer. Over here, it's in standard form already, so we just have to figure out A, B, and C. So A in this case is 9, B is negative 18, and C is 7. So you can kind of see if the numbers are a little bigger than normal, then this does get unpleasant really fast. So x equals a negative 18 plus or minus the square root of negative 18 squared minus 4 times 9 times 7 all over 2 times 9. Alright, well a negative negative is a positive, so it's positive 18. I would go to a calculator at this point, so 18 squared, we get 324. 4 times 9 times 7, we get 252 all over 18. Alright, so 324 minus 252, we get 72. And now we're going to talk about that square root for a second. Alright, so 72, if I'm looking for the biggest perfect square that goes into that, would be, let's see what goes into that. Let's see, 9 does, and 4, oh, 36. Okay, so we're going to split that up into 36 times 2. Okay, so I can bring a 6 outside of the square root. That square root of 2 stays behind. Alright, so about the best I can do is I can divide the 18 out and then 6 over 18. So I get 1 plus or minus square root 2 over 2. And that's about as far as we can simplify that particular problem down to. It's not too bad. Okay, sorry, I just caught this. 6 over 18 is not over 2, it's over 3. Okay, so before we leave solving quadratics, I just want to take one more attempt at pointing out when you would want to pick a certain method. So for starters, always try to factor. Factor is the easiest and the quickest of any of the methods. So you always want to try to factor first. If you happen to notice that there is no linear term, so the b term is gone, or you happen to notice that it looks like some expression squared equals a number, then square root is pretty much the best method to get that done. Completing the square is convenient and it works nice if you have a leading coefficient of 1 and your linear term happens to be even. Then completing the square is probably one of the fastest ways to get it done. And as a last resort, so unless the directions tell you otherwise that you are forced to pick a particular method, last resort, then you can go ahead and use the sledgehammer of math or the quadratic formula. And that will actually solve any quadratic equation. So it's always an option. You can always get away with it. Just be aware that it is a little on the cumbersome side as far as steps involved to get the answer right. Okay, one little, I guess, bonus topic, I don't know if it's a bonus topic, but I'm going to treat it as such, is dealing with what's called the discriminant of the quadratic equation. And the discriminant is this b squared minus 4ac. It's that component that's inside the square root. Now, what the discriminant actually tells us is it doesn't tell us the actual answer, but it does allow us to identify the types of solutions that we would end up with. So if b squared minus 4ac happens to be a positive number, then there are what are called two real solutions to the equation. Now that actually corresponds graphically, if you think about a parabola, quadratic, means that it crosses the x-axis twice somewhere. And it's possible for us to see those numbers. They could be whole numbers, they could be fractions, they could be square roots, but I know there's two real solutions. If the discriminant happens to be 0, then I know there's only one real solution. And the reason why there's only one real solution, again going back to my picture here, that means the quadratic, or the parabola, is sitting on the x-axis somewhere. So it only crosses it at one location. And if we happen to have a negative discriminant, we have what are called two imaginary solutions. So we have two, well, I shows up is the point. So if you get a negative inside the square root, you know you're going to have an I as an answer. And graphically what that means that the quadratic doesn't actually physically cross the x-axis anywhere. Now, before you think, well, because it's imaginary, it doesn't matter. Imaginary solutions are very powerful when it comes to electronics and magnets and computer programming. Um, that's beyond the scope of this particular course, but the concepts that are connecting imaginary numbers are why a lot of us have cell phones, and I don't think anyone would ever complain about having access to a cell phone. So anyways, hopefully that helps.